Water covers 70% of our planet, and it is easy to think that it will always be plentiful. However, fresh water, the stuff we drink, bathe in, irrigate our farm field with, is incredibly rare. Only 3% of the world's water is fresh water, and many of the water systems, such as rivers, lakes, and aquifers that keep ecosystems thriving and keep a growing human population, are drying up or becoming too polluted to use. Thus, water pollution remains as the top environmental concern around the world. What causes water pollution? There are 4 general categories of water contaminants. Physical contaminants primarily impact physical appearance or other physical properties of water. There is sediment or organic material suspended in the water of lakes, rivers, and streams from soil erosion. Chemical contaminants are natural or man-made compounds, including excess nutrients, bleach, salts, pesticides, metals, drugs, and toxins produced by bacteria. Biological contaminants are organisms in water, also referred to as microbes or microbiological contaminants, such as bacteria, viruses, protozoa, and parasites. Radiological contaminants are chemical elements with an unbalanced number of protons or neutrons, resulting in unstable atoms that can emit radiation, including cesium, plutonium, and uranium. How do pollutants get into the water bodies? There are mainly 2 types of water pollution sources: point and non-point. Point source refers to contaminants coming from a single source, such as wastewater discharged legally or illegally. Non-point source refers to contaminants whose origins are diffused, such as agriculture or stormwater runoff, or debris blown into waterways from land. What happens to water when it is polluted? Eutrophication is the leading cause of impairment of many freshwater ecosystems in the world. Eutrophication is characterized by excessive plant and algae growth due to the excess of nutrients for plants, such as nitrogen and phosphorus. For example, a large bloom of blue-green algae took place in Taihu Lake in 2007. Ocean acidification is another example. The ocean absorbs as much as a quarter of man-made carbon emissions. When carbon dioxide is absorbed by seawater, a series of chemical reactions occur, resulting in the increased concentration of hydrogen ion, which leads to increasing acidity. Increasing acidity has possibly harmful consequences, such as depressing the immune response of blue mussels and coral bleaching. How to protect our water resources? China has issued Law of the People's Republic of China on Prevention and Control of Water Pollution, which was revised on June 27, 2017, to promote protection and improvement of the water environment. To maintain public health, water must be carefully managed in every part of the water cycle. Wastewater treatment. Water after use becomes wastewater and must be treated before being discharged back into the environment. Traditional wastewater treatment process includes primary treatment, which involves the separation of macrobiotic solid matter from the wastewater. The secondary treatment stage involves adding bacteria to the wastewater to ensure that it is broken down further. Next, wastewater must be disinfected with chlorine or UV radiation. However, traditional wastewater treatment can't cope with new types of pollution. Today's pollutants, such as heavy metals, chemical compounds, and toxic substances, are more difficult to remove from water. Therefore, advanced waste treatment techniques are in use or under further development. And sustainability is an important principle. With the technology of anoxic fermentation, wastewater can be transferred into methane, which can be used for energy production. Lake restoration. In general, rehabilitation of eutrophic waters involves three components: control of pollutant sources, restoration of damaged ecosystem, and catchment management.
Over the past 3 decades, many conventional and novel methods that use physical, chemical, and biological processes have been applied to improve and eliminate contaminants in eutrophic lakes. Among the three, biological processes are considered to have less adverse effects on the environment.
One example is man-made cultivation of aquatic plants. It is an effective way to control, regulate, and inhibit eutrophic environments. Aquatic plants can effectively absorb nutrients during their growth and can remove, destroy, or isolate harmful substances from the environment. Now, let's watch a video of an example about the comprehensive treatment of the South Lake on our campus.